We learned about the concept of route redistribution back in the Route Complete video course, and we said that route redistribution allows routes that are learned from one routing source, maybe like a routing protocol, maybe a directly connected route, maybe a statically configured route, but we learn routes from some source, and those routes can be injected into a specific routing protocol. For example, we could redistribute routes from OSPF into EIGRP. And before we get into troubleshooting route redistribution, let's take a few moments and review the basics. First, why would we want to do route redistribution? Well, one reason we might want to do route redistribution is we've got an enterprise network and it's running more than one interior gateway protocol. Maybe because there's been a company merger. Company A merged with Company B and one was running OSPF and the other was running RIP version 2. We might need to redistribute between those two different interior gateway protocols. Maybe we've got different departments within the enterprise that are under different administrative control. Or perhaps we've got a partner company. It's not our enterprise, but it's a company we do a lot of work with. Maybe we want to connect out to those partner networks. And we don't have to do route redistribution just between interior gateway protocols. We could redistribute between an interior gateway protocol and an exterior gateway protocol, specifically BGP, Border Gateway Protocol. Maybe we want to advertise our routes out to our service provider, and we've got a BGP peering relationship with that service provider. Or maybe the reverse is true. We want to take BGP learned routes and redistribute those, or maybe a subset of those, into our IGP. As an example, let's think about this router. It's got one interface in one autonomous system and another interface in a different autonomous system. The interface on the left is connected into an EIGRP autonomous system, and the interface on the right is connected into an OSPF autonomous system. And what we could do is take routes known to EIGRP and inject those into OSPF. Similarly, we could take routes known to OSPF and inject those into EIGRP. That would be an example of mutual route redistribution. That's where we've got a couple of different routing protocols, and each routing protocol is sending its routes into the other routing protocol. And when we configure route redistribution, here's a key point to keep in mind. Oftentimes it can get confusing in which direction the redistribution is happening. If I go into router EIGRP 100 configuration mode, I'm in the router configuration mode for an EIGRP autonomous system, and if I give the redistribute command there under EIGRP router configuration mode, what am I saying? Am I saying that I want to take EIGRP learned routes and redistribute them somewhere else? No, what I'm saying with the redistribute command is redistribute routes from the specified routing source that we're going to specify in the redistribute command, redistribute those into this routing protocol. In my case, I'm in EIGRP router configuration mode. I say redistribute, and maybe I'm redistributing OSPF. I'm redistributing those OSPF routes into EIGRP. And here's something to keep in mind that's not obvious. When I say that I want to redistribute routes learned by a specific routing protocol, it's not just routes learned by that protocol. It also includes routes to networks on directly connected interfaces. And those interfaces are enabled for this routing protocol. Those will be redistributed as well. But one of the big challenges we have with redistribution is routing protocols use different metrics. They've got different criteria for what makes up a metric. OSPF's metric is based on bandwidth, and by default, EIGRP's metric is based on bandwidth and delay, even though it can consider other things depending on our K values. RIP, its metric is based on hop count. How many routers do we have to transit in order to get to this network? And it really doesn't make any sense to try to do something like this. We could not say, for example, if an OSPF route has a metric of 10 and we're redistributing it into RIP version 2, then give it a hop count of 3. It really doesn't make sense to do something like that because these routing protocols are calculating their metrics very, very differently. So what can we do? Well, there are some default seed metrics. A seed metric can be assigned by default to a route as it's being redistributed into a routing protocol. That's if we don't manually configure a metric ourselves, which we can do. And different routing protocols have different seed metrics, and I want you to understand what those are. Let's populate this table to see what the default seed metrics are for various routing protocols. The default seed metric for RIP is infinity. If we redistribute a route into RIP, by default, RIP is going to consider that route unreachable. The default seed metric for EIGRP is also infinity. However, it's a bit different with OSPF. With OSPF, if we redistribute a route into OSPF, that route is going to inherit a default seed metric of 20, unless we're redistributing from BGP. That's an exception. If the route is being redistributed from BGP, in that case, it's going to have an OSPF metric of a 1. And BGP is an interesting one. It's going to use whatever the IGP metric value is as the default seed metric. That means if we're using EIGRP and we're redistributing into BGP, it might have a metric of 1,000,000. It might be 10 if we're using OSPF, but BGP is going to assign whatever the metric value is of the IGP. And now that we've reviewed some of the fundamentals of route redistribution, we've discussed why we need it, what does it do, what are the default seed metrics. Let's go out to a live interface and review a basic route redistribution configuration, and then in our next video, we'll get into troubleshooting route redistribution. Here on router R2, we're going to configure the route redistribution because it's the boundary router. It's got an interface in the OSPF autonomous system. It's got another interface in the EIGRP autonomous system. This is the place where we're going to set things up. Let's see what the router configuration looks like right now on R2. Let's do a show run pipe to section router, and we get to see both the EIGRP and the OSPF router configuration. And we see that for EIGRP, interface serial 1/1, if you look at the topology, is participating in EIGRP, and the OSPF autonomous system includes our loopback 0 interface as well as serial 1/0. Now let's set up mutual route redistribution. Let's start by redistributing OSPF learned routes into EIGRP. I'll go into router, EIGRP autonomous system 1 configuration mode, and I'll say redistribute. And what do I want to redistribute? It's OSPF. I'm redistributing into EIGRP. I'm redistributing OSPF with a process ID of 1. And I could enter a metric here. I could say, here's the metric for routes learned via OSPF. I could do that. And I could give a different metric for a different routing source, maybe like static routes that I was going to be redistributing into EIGRP. However, I'm just going to enter this, and I'm going to set up a default metric, which will apply to all routes being redistributed into EIGRP. I'll say that the default metric has these 5 components. Remember, the metric for EIGRP is made up of bandwidth, delay, reliability, load, and MTU. MTU is not really used in the calculation, but it's designed to be a tiebreaker. And by default, only bandwidth and delay are considered, but we can manipulate the K values to make load and reliability also be considered. But here, I'm going to say that my bandwidth, and the unit of measure is in kilobits per second, I'm going to say I've got a T1's worth of bandwidth. That's going to be 1.544 megabits per second in kilobits per second. That's 1544. I'll say that my delay is 10, and the units of measure there are in tens of microseconds. I'll say that my reliability is at 100%, 255. I'll say I'm minimally loaded with a load of 1, and my MTU is going to be the default maximum transmission unit of 1500 bytes. Once I've done that, I should now be redistributing OSPF known routes into EIGRP. Let's see if that's true. Let's go to router R3, which is entirely in the EIGRP autonomous system, and let's see if we've learned anything. Let's do a show IP route. Great news I have. I've learned about the loopback IP address on R1, the loopback IP address on R2. I've learned about the network connected off of Fast Ethernet 0/0 on R1, and I've learned about the network interconnecting R1 and R2. That's great news. However, just because R3 knows about these networks and how to get to those networks, that's no guarantee that we can set up a conversation with a host on one of those networks. For example, let's try to ping 1.1.1.1. It's in the IP routing table. Can I get there? Well, the pings are going to fail. Why do they fail? Well, I'm getting to 1.1.1.1. However, that router R1, it does not know how to get back to me. And as a result, all of the pings fail. We've only redistributed in one direction. We've redistributed OSPF into EIGRP. Let's go in the other direction now. Let's go to R2 and let's go into router configuration mode for OSPF process ID 1. And let's say redistribute EIGRP autonomous system 1. And I could say that I wanted to specify a metric at this point, but remember OSPF does have a default metric it's going to assign to redistributed routes. It's going to be a metric of 20 unless that redistributed route is coming from BGP. In that case, the metric is going to be 1. But here I'm just going to leave it at the default of 20. Something that we typically want to do is include the subnets keyword. The subnets keyword will cause us to redistribute all OSPF known routes into EIGRP. If I do not give the subnets keyword, we're only going to be redistributing classful networks. In fact, if I just press enter right now, if I don't give the subnets keyword, I get a bit of a warning. It says that only classful networks are going to be redistributed. Let's prove that. let's take a look at our OSPF database. I can do a show IP OSPF database command, and I'm looking for type 5 LSAs. A type 5 LSA would represent a network that we learned from another autonomous system, and I don't see any right here. And just as an experiment, let's create another network on R3 in the EIGRP autonomous system that does have a classful subnet mask. I'm going to go to R3, and just as a test, let's create interface loopback 1, and let's assign an IP address of 4.4.4.4, and I'm going to give it a classful mask. The 4 in the first octet tells us this is a Class A network. A Class A network has an 8-bit subnet mask. Our subnet mask is going to be 255.0.0.0. Now, I'm not recommending you do this in the real world. This is just an experiment. Now, let's see if that network, that classful network, did it get redistributed into OSPF. Let's go back to R2 and let's once again say show IP OSPF database, and look at this. We've got a type 5 LSA representing that classful network. So at this point, we will redistribute any classful networks, but I don't have any other networks that have a classful mask. How do I fix that? Well, in production, you'll typically want to use that subnets keyword. Let's go back into router configuration mode for OSPF process ID 1. And I'm going to say redistribute EIGRP autonomous system 1. This time, I'm going to include the subnets keyword. And once I do that, let's take a look at the OSPF database. I'll do a show IP OSPF database command. And great news, we have plenty of type 5 LSAs now. We know about all of those networks. At this point, R3 should be able to ping the loopback interface on router R1. Can I ping 1.1.1.1? Let's test it out. And I can, success. And if I do a show IP route, we can see from these EX codes that these are networks learned from an external autonomous system. If I go to R1, let's do a show IP route. And the E2 codes, that tells me that these are networks learned from an external autonomous system. Now, by the way, E2, I could have caused those to be an E1. Let me show you how I would have done that. Let's go back into router OSPF configuration mode. And in that redistribute command, I could have said metric type. And I could have specified an E1 or an E2 route. Do you remember the difference? By the way, E2 is the default, as we saw on R1, but the difference is when a route is being redistributed as a type 2 external route, then its metric is going to remain the same. It's going to be the metric assigned by the ASBR, by the Autonomous System Boundary Router, regardless of how many router hops it has to go through within an OSPF area. It's still going to have that original metric assigned by the ASBR. And if I'm 3 router hops away and I say, what's the metric to get back to this network? It's going to be the same metric as the ASBR reported. You might think, well, that's not terribly accurate. I want to consider the cost to get from this router back to the ASBR, and then we'll consider that other metric. If you want to consider the metric to get from a router to the ASBR and add that cost onto the cost advertised by the ASBR, that's where you would need to set the metric type to 1. That would be an E1 instead of the E2 that we have by default. An E1 route, it will consider the distance to get to the ASBR and then add on to that the distance or the cost to get to the destination network. And now that we've reviewed the basic route redistribution configuration, let's take a look at our next video at a trouble ticket.